It's a development of the idea of linear dependence and linear independence. It's called basis. We have 3 minutes, and that's basically the definitions only, so it's enough to cover this slide. And next time I'll show you some examples of this. So here what we do, if I have a vector space, here's my quadruple. And if I have a set of vectors fixed in my vector space, here's a new definition for you. This set is called basis. The set B is called basis when two things are satisfied, which I call A and B. A says that B should be linearly independent. It's one requirement. And the second requirement says that the B must be the spanning set. That is, my V coincides with the span of S. Yeah, that's one definition. The other thing is this. If I have a vector now in my vector space, if I have a basis, which is subject to this definition, if I have a vector in my vector space, then because my set, I said S, that's a typo, obviously, it's a B, it should be B. Because my B is spanning, for this vector, I can find a linear representation, like so. I can find a linear representation like so. Here it is, with some coefficients from my number field. And because of the lemma on my previous slide, we know that this set of coefficients is unique because the set is linearly independent. So you see, for any vector in my vector space, if I have a basis, I can find a linear representation, and that representation is unique. And that actually explains why this unique set of coefficients, we will have a special name for it. We will call it this n-tuple of coefficients. This n-tuple of coefficients, lambda 1, lambda 2, lambda n. We will have a special symbol for this n-tuple. Here's a symbol. A in the square brackets, vector A in the square brackets with a B, the set with respect to which you find the coefficients, as a subscript. We call this the coordinate vector of vector A with respect to basis B. The coordinate vector of A with respect to basis B. This example, this vector A, we now know this vector A comes from the span. So if I take my B consisting of my two first vectors in this set, this B, it is linearly independent. We established that here. First time we visit this example. And B at the same time is a spanning for the span of B. I don't know, it's another typo, it should be B here. Right, if you take a span of B, obviously B will be the spanning of the span of B. So what I'm saying is that B is a basis for this choice of the vector space. And my vector A, this vector A, comes from this vector space. So if you ask me what will be the coordinates of my vector A with respect to this basis B, here they are, -1 and 3. Right from here, first coefficient -1, second coefficient is 3.